Bismillahirrahmanirrahim. With the name of Allah, who is very kind and merciful. Welcome to my Topper Student channel. In this channel, you will find the solution of mathematics and computer science for OE level. Today we shall discuss question number 11 of paper 1 mathematics 1 session by June 2023. In order to search this channel on the YouTube, please use the word my topper student. You will find the channel my topper student. For the online tuition, please contact on this WhatsApp number. For question number 11, the equation of a circle is y equal to k 4x plus 1 under root minus x plus 5, where k is a positive constant. Part A, find dy over dx. So first of all, we shall solve the part A of this question. For the solution of part A, we shall find out the derivative of the given curve. So differentiate with respect to x, dy over dx equal to k. In case of derivation, we take the power first. After that, we minus 1 from the power and then take the derivative of the base. Derivative of minus x is minus 1 and derivative of constant is equal to 0. We know that derivative of the constant is equal to 0. After simplification, dy over dx equal to 2x over 4x plus 1 under root minus 1. Now in part B, find the x coordinate of the stationary point in terms of k. Now we shall find out the stationary point in terms of k. We know that in order to find out the stationary point, we put dy over dx equal to 0. So in part A, we have find out dy over dx, which is equal to 2k over 4x plus 1 under root minus 1 equal to 0. After simplification, we get x equal to 4x square minus 1 over 4, which is the stationary point in terms of k as required in the question. So part C, given that k equal to 10.5, find the equation of the normal to the curve at the point where the tangent to the curve makes an angle of tan inverse 2 with the positive direction of x-axis. Now we shall find out the equation of the normal when k is equal to 10.5 and tangent angle is equal to tan inverse 2. So in the solution section for part C, from part A, the dy over dx is equal to 2k over 4x plus 1 under root minus 1. As given in the question statement of part C, k equal to 10.5. By putting the value of k, we get dy over dx equal to 21 over 4x plus 1 under root minus 1. As given in the question statement, the value of the tangent angle is equal to 2 because theta is equal to tan inverse 2 as given in the question statement. So we shall put 2 equal to dy over dx, value of the tangent, which is equal to 2. So after simplification, we get 4x plus 1 under root equal to 7, squaring both sides, and after simplification we get x equal to 12. Put x equal to 12 and k equal to 10.5 as given in the question statement. After simplification we get y equal to 66.5. So the point is, x point is 12 and y point is 66.5. As tangent to the curve is 2, tangent to the curve is equal to 2, this one. We know that when the tangent is given, we can find out the normal tangent to the normal. So the tangent to the normal will be minus 1 by 2 because the formula in order to find out the tangent or the normal tangent is equal to m1 into m2 equal to minus 1. So in this case, the equation of the normal is y minus y1 equal to minus 1 by 2 into x minus x1. After simplification, we get y equal to minus 1 by 2x plus 72.5, which is the equation of the normal. Thank you for watching the solution prepared by senior A-level teacher. Wish you good luck for your exam.